Hey guys, Mr. Brown here, and this presentation covers section 1.6 from the Openstax Chemistry Adams First Second Edition textbook. And this section concerns a technique that chemists and other scientists refer to as dimensional analysis. So we're going to look at how some units are divided along with the math to arrive at a derived answer or a derived figure. And then at the very end of this lesson, we'll also take a quick look at temperature conversion, because those are a little less straightforward than some of the other conversions that we'll talk about in the presentation. So if you'll follow along, I'll see you on the next few slides. Okay, so what is this thing that we call dimensional analysis? Really, it's just a fancy way of saying it's how we convert between different units of different measurements in chemistry. It's a lot like the conversions that we did with the SI units earlier in the class a week or so ago, but now we can mix multiple different types of units in together and convert between the two. It usually or almost always requires knowledge of something we call conversion factors. And for the most part, you will be given those conversion factors in a lot of cases, and we'll talk about how to use them going forward. It's important to remember that units can have the same mathematical operations as numbers carried out on them. So you can divide units like we've seen in the derived units for density, where we have grams divided by milliliters. Whereas we might read that grams per milliliter, that's still written mathematically like you would with numbers. If a unit, this is the important part, if a unit is divided by itself, it cancels out, essentially becomes one, and we can toss that unit out. And that's how it becomes useful for conversions. We have some examples on the next few slides that hopefully will help you clear this up a little bit. So what we have here is a typical question that could be answered by using the method that we call dimensional analysis. You see the question here: how many inches are in 15 centimeters? In other words, if you have a 15 centimeter object, how long is that object in inches rather than centimeters? Well, to even approach that problem, what we need is the conversion factor that we talked about on the last slide. So you need a piece of information to tell you the relationship between inches and centimeters. We have that relationship right here, our conversion factor. 1 inch is equal to 2.54 centimeters. You can write that one of two ways, or you can show that relationship either of these ways. You can show it as 1 inch over 2.54 centimeters, or alternatively, you can use it as 2.54 centimeters per 1 inch. And you can use those as calculation factors for any conversion of inches to centimeters. Let me show you how this works. So to get the answer to this question, I'm going to first put what I know, the 15 centimeters. I put it over 1 just for prosperity, because we'll have a lot of these divisions going forward. So if I ever have a unit kind of by itself, I'll put it on 1 over 1, because that doesn't change anything. 15 centimeters divided by 1 is still 15 centimeters, and it helps me line my conversions up. You'll see how that works just soon. So after I put my 15 centimeters, I'm going to put my conversion factor in a way such that my unit that I want to disappear, in this case centimeters, is opposite of where it was just before. So to cancel it out, in this case centimeters was on the top of the divisor. So on the next multiplication, I need it on the bottom. What that basically equals out to is it shows you that to determine the amount of inches in this measurement, you need to take 15, multiply it by 1, and divide it by 2.54. Also, because of the way we have our units displayed here and shown here, we have a centimeter in the numerator and a centimeter in the denominator. That means these two can cancel out, leaving us with the units that we want, inches. When we complete 15 times 1 divided by 2.54, the result is 5.91. And since we have just the inches unit left over, we write the inches unit there to show that our answer to this question is 5.91 inches. As with many things, we will go through some examples here to hopefully clear some of this up for you. The first example we have here asks, if I have 15.2 kilograms of oranges, how much do the oranges weigh in pounds? 1 kilogram is equal to 2.204 pounds is given to us as our conversion factor. So like I said with the last one, I start these off by writing out the information that they're giving me, 15.2 kilograms. And I know I can put that over 1 to keep everything in line. I know that the answer I want needs to be in pounds. I'm going to use my conversion factor. 1 kilogram equals 2.204 pounds. And I can write that either way. I can place that conversion factor in this space, either in this configuration, 1 kilogram per 2.204 pounds, or I can write it as 2.204 pounds per 1 kilogram, or 2.2 pounds per kilogram, essentially. Remember, I want to choose the conversion factor that allows me to cancel out the kilograms because I don't want to be left with pounds in this case. Since kilograms is in the numerator here, I want to pick the conversion factor with the kilograms in the denominator, which would be this guy here. So here I'm going to put 2.204 pounds per 1 kilogram. Because kilograms is on top here and kilograms is on bottom here, when I perform the calculations, kilograms will be canceled out, leaving me with pounds, which is what I want my answer in. Furthermore, this operation says to do 15.2 times 2.204 divided by 1 times 1. And so that essentially works out to 15.2 times 2.204 divided by 1, which is essentially 15.2 times 2.204. So I will take 15.2 and multiply it by 2.204. The answer that the calculator returns is 33.50008, but I know from the previous lecture that because I have 3 significant figures here, my answer should be in 3 significant figures. So therefore, my answer will be 33.5 pounds. Here we have our next example. How many gallons are in 412.4 liters? And they give us the conversion factor. 1 gallon equals 3.79 liters. So again, let's go ahead and set up our conversion factor so that we can have a set of factors to choose from. If we have 1 gallon per 3.79 liters, we can either write the conversion factor that way, or we can write it 3.79 liters per 1 gallon. Those two conversion factors say the same thing. For every 1 gallon of liquid, you have 3.79 liters, or for every 3.79 liters, you have 1 gallon of liquid. Therefore, we can start with what we know. We have 412.4 liters, and we can put that over 1 for appearances if we want to. Multiply it by our conversion factor. Again, We're trying to cancel out liters here and get 2 gallons. So we're going to pick the conversion factor that leaves us with gallons on top and cancels the liters on bottom, since liters is on top to begin with. I will use the conversion factor that says 1 gallon per 3.79 liters. When I multiply that through, the math tells me to do 412.4 times 1 divided by 1 times 3.79. That will essentially work out to 412.4 divided by 3.79. The answer to which is 108.8126649. Again, I can see that my lowest number of sig figs is 3.79 liters. So I am going to keep my answer to 3 significant figures. That would result in an answer of 109. Sorry, scratch that. That needs to be, no, that's right, 109 gallons. Here we have another dimensional analysis problem, but it's disguised as one of our density problems. Our densities can actually be thought of as a form of conversion factor. They tell us that for a substance, so many grams of that substance are in 1 centimeter cubed or 1 milliliter. So for gold, the density is 19.3 grams per centimeter, and we can write that as a conversion factor just as it's written, 19.3 grams per centimeter cubed. We can also flip that around just like we've been practicing so far. We can also say 1 centimeter cubed per 19.3 grams of material. Both of those relationships say the same thing, so we can use it whichever way we need. We'll start with what we know, 529.3 centimeters cubed of gold. I'll put that over 1 just to keep everything in place. I'm going to multiply it by my conversion factor to figure out how many grams that is. So I'm trying to cancel out the centimeters cubed. I'm going to use the conversion factor that has the centimeters cubed in the denominator because it's in the numerator first. I take my 19.3 grams per centimeter cubed. These centimeters cubed will cancel out, and I'm left with 529.3 times 19.3 divided by 1 times 1. And so therefore, the whole problem works out to 529.3 times 19.3. That returns a figure of 102.15.49. But again, I want to round that to 3 significant figures. And so that will round to 10,200 grams. In this example, we are asked what the value of that sample of gold would be if the price of gold is $59.13 per gram. I often find people are somewhat confused by this topic until we get to the money, and then all of a sudden everybody can do it. And a lot of times it just seems to make more sense because these are conversions that you've made with money all your life. So we remember from the previous example that we have approximately 10,200 grams of gold. We have a conversion factor given to us in the example. Now this time it's not exactly spelled out for you, but if you read the text of the problem, then you see that our conversion factor is 1 gram is $59.13. You can also write that $59.13 per gram. And we can set this up just like any other conversion factor. We want to get rid of the grams, so I'm going to write 10,200 grams, and I'm going to put it over 1 for placement. And then I'm going to pick the correct conversion factor. I want grams to cancel out. Grams is initially in the numerator, so I'm going to pick the conversion factor with grams in the denominator. It shows 59.13 per gram. Our grams will cancel out. And we see that the problem tells us to do 10,200 times 59.13. Divide it all by 1 times 1. We don't really have to worry about that. 10,200 times 59.13. Well, I show that as $603,126. We have to round that to 3 significant digits because our 102,000 or our 10,200 only has 3 significant digits. So our $603,126 becomes $603,000. We would lose $126 to our significant figures, but I don't think anybody is complaining about an extra $126 on top of their $603,000. All right, on this slide, I've stuck with the money theme because, again, I think people find it kind of useful or easier. But we also have a multi-conversion type of problem here on this slide. I'm going to show you how to do it step by step on this slide, and then on the next, I'm going to show you how dimensional analysis can shorten that work up. So let's start by reading the problem that we have here. You have found a luxurious Italian sports car that you plan to save up for. The price of your hand-built automotive utopia is a cool 325,000 euro. After expenses, you are able to save about $25 per week. With these conditions, how many months are you going to have to save to afford your new transportation? So we're given a good deal of conversion in here. Some of it I've written out that may not be too apparent. And I had to go look up the conversion of dollars to euros, which on January the 24th, 2022 was 1 euro is equal to $1.13 US American dollars. So we'll just go with that as our conversion. Remember, all of these conversions we can write either with as they're written or flipped around, units on top or bottom, however you need to use them. So let's think about this step by step. I want to know how many months it's going to take me to save up this 325,000 euro, and I know that I make $25 a week, or I'm able to save $25 a week. So I think the first thing I would do is figure out how many dollars 325,000 euro is. So the first one will look like this: 325,000 euro times there are $1.13 or $1.13 in 1 euro on January the 24th anyways. If you multiply that through, we see that 325,000 times 1.13 will come up to $367,250. So 325,000 euro is equal to $367,250. We're going to treat that as an exact conversion without the significant units to get the point across here. So if I want to know how many weeks that will take me to save at a rate of $25 per week, I can take my $367,250 and I can multiply that by 1 week, gives me $25. Now I was able to bring that from this conversion factor here, but I just flipped it around because I want to cancel out the dollars and be left with weeks. That math essentially tells me to divide 367,250 by 25, which tells me I need 14,690 weeks to save up for that car. Now, if we notice, the final answer doesn't ask for weeks, it asks for months. So now we need to convert our weeks to months. So if I take my 14,690 weeks, and I may throw that over 1 just for bookkeeping, and I multiply it by my conversion factor here, there's 4.33 weeks in every month. I'm going to put month on top because I want the weeks to cancel out. 1 month is 4.33 weeks. Our math there shows us that we should divide 14,690 . And that shows that I need 3,392.6 months to save up for my luxurious Italian sports car. At a rate of 52 weeks per year, that's going to take me approximately 600 years to save up for, but hey, we'll get it one day, right? All right, guys, so we have the exact same question here on this slide, but I'm going to use it to show you how dimensional analysis can kind of shorten up all that work for you. I'm going to start by writing down the same thing that I wrote down to begin with on the last one. I know I'm starting with 325,000 euro, and I know that I'm trying to get to an answer of months all the way down here on the other side. I want my answer in some kind of month. I'm going to put that over 1 for placement, and I will start my multiplying with all of my units. The thing is, with dimensional analysis, we can string all of these conversions together as long as we cancel out everything and get to the unit we want to. So I know I'm trying to get rid of euros, so I'm going to use the dollar conversion on the next one. I know it's 1.13 dollars per 1 euro. This will cancel out my euros for me. I can also put 1 week gives me $25, which would cancel my dollars for me and just leave me with weeks. But I don't want just weeks. I want to go to months. So now I'm going to cancel out the weeks. I have a conversion that says 1 month is 4.33 weeks. And so if I cancel out weeks, I am left with the unit that I want, months. So therefore, all I have to do is perform the math that my multiplication and division show there. So I multiply everything across the top, and then I multiply everything across the bottom, and I divide like it shows. So for the top, I will multiply 325,000 times 1.13 times 1 times 1 and that shows a value of 367,250. And then I will divide it by 1 times 25 times 4.33. But it's important that I multiply all that first. So I'll multiply 1 times 25 times 4.33. And divide 367,250 by that result. So it looks like this. So if I take everything and multiply it on top, I get 367,250. If I take everything and multiply it on the bottom, I get 108.25. And then if I perform this operation right here, I should get the answer that I want. 367,250 divided by 108.25 equals 3,392.6 months. Just as we had the answer on the previous slide, we get the same answer here, even though we didn't take it step by step by step. I mean, we essentially did, but all we did was laid out our conversions and our known information in a way that we cancel out the units that we don't want and end up with the units that we do want. So if we were doing this with significant figures, we see that we have 3 significant figures here, 3 significant figures here, only 2 significant figures here, so technically our answer should have 2 significant figures. So we could round up and say it would take 3,400 months for us to be able to afford our Italian sports car. Probably need a better job if we ever want to actually drive our Italian sports car. All right, on this slide, we have a little bit different problem because in this time we're being asked to determine a number that is in miles per hour. So it's not just a single unit, it's a combined unit. And we'll see how that works. The problem asks, it is the year 2322, and we finally have our sports car. You take it out on I-3457 to see what she's got, and you're able to top it out at a whopping 325 kilometers per hour. What is the speed in miles per hour? So to do this conversion, you need the information. You can Google this often if you're not given these things, but you need the information that 1 mile is equal to 1.609 kilometers. So that's going to be our conversion factor for the problem. We can write that either way. We can write miles on top or kilometers on top, depending on what we need to cancel out. What we're given here is we know that we can get our car to 325 kilometers per hour. We want to multiply that by a conversion factor we know to get rid of the kilometers, but we actually want to leave the hours, if you'll notice. We're lucky here because we can write 1 mile per 1.609 kilometers, or we can write 1.609 kilometers per 1 mile. They both express the same relationship. We're going to use this one because we want to get the kilometers out of the way, we want to cancel it, so we're going to pick the one on the bottom here. 1 mile is 1.609 kilometers. And so our problem or our work there tells us that if we take 325 times 1 and divide it by 1 times 1.609, it essentially is the same thing as 325 divided by 1.609. And so that comes up to 202 miles, excuse me, not kilometers, we've canceled out kilometers, But remember, we have our miles still. The kilometers are canceled out, and we have our miles. But if you'll notice, we didn't cancel out our hours, so we also have our hours in that denominator, just like we need miles per hour. So 325 kilometers per hour means that our sports car tops out at around 202 miles per hour. Here in our first example, we will convert the temperature of 34.5 Kelvin to both degrees Celsius and degrees Fahrenheit. We remember from the previous slide that to convert from degrees Celsius to Kelvin, the formula we will use is the temperature in Kelvin minus 273. To convert from Kelvin to Fahrenheit, the formula we will use is the Kelvin temperature minus 273 times 9/5 plus 32. So to do the first one is really pretty straightforward. Degrees Celsius would be equal to the Kelvin temperature, 34.5, minus 273. If we plug that into our calculators, it turns out that 34.5 is negative 238 degrees Celsius, 238.5 degrees Celsius. If we perform the Fahrenheit conversion, the formula we arrive at should look like this. Fahrenheit equals 34.5 minus 273 times 9/5 plus 32. Notice we will do the subtraction first because it's in parentheses, so I'll go ahead and simplify that. 34.5 minus 273, we've already determined, is negative 238.5 degrees. Times 9/5 plus 32. So then we will multiply negative 238.5 times 9/5, and that is equal to negative 429.3 plus 32. The degrees Fahrenheit should be negative 397.3. So we can see that 34.5 Kelvin is quite a cold temperature, coming out to negative 238.5 degrees Celsius and negative 397.3 degrees Fahrenheit. Here on this slide, we will convert 4002.4 degrees Fahrenheit to both degrees Celsius and Kelvin. We may remember from the previous slide that to convert from Fahrenheit to Kelvin, the formula we will use is the degrees in Fahrenheit minus 32 times 5/9 plus 273. We'll also remember that to convert from Fahrenheit to degrees Celsius, the formula we will use, the temperature in Fahrenheit minus 32 times 5/9. And we probably can notice that there is not much difference in these two formulas other than the plus 273 here in this spot. So if we figure out the Celsius first and then add 273 to it, we can sort of figure them both out in a series of steps. So we'll do the degrees Celsius first. Degrees Celsius equals degrees Fahrenheit, 4002.4 minus 32 times 5/9. That's just a simple calculation in our calculator now. 4002.4 minus 32 times 5/9. That comes up to a figure of
2205.7 degrees Celsius. And then to take it to the Kelvin, all we must do is add the 273 that we see here. So we will take our 2207.5 and add 273 to that total. And so the Kelvin temperature would equal 2478.7.